Phineas Gage, Chapter 4, Putting Phineas Together Again. In our time, Phineas Gage is a textbook case. Students of neurology or psychology study his case because it illustrates how the lobes of the frontal cortex, the two halves of your brain that meet in your forehead, are the seat of executive functions. Those are your abilities to predict, to decide, and to interact socially. Unfortunately, Phineas is not the only person to have suffered damage to the frontal cortex. Antonio and Hannah Damasio, a husband and wife team of doctors, regularly see people who remind them of Phineas Gage. The Damasios are renowned brain researchers at the University of Iowa hospitals and clinics in Iowa City and treat patients with the same kind of frontal lobe damage that afflicted Phineas. Like Phineas, these patients with frontal lobe damage have trouble making decisions. Like Phineas with his $1,000 pebbles, they perform well on logic and math tests, but make strange choices in trading situations. Their emotional responses are unpredictable. They seem out of step emotionally with the rest of the world. The patients who come to the Damasios clinic are not victims of blasting accidents. Their brain injuries usually follow surgery to remove a tumor from deep inside the frontal cortex. This kind of brain surgery is strictly a last resort to save a patient's life, because even if the operation goes well, the risk of side effects is high. Any damage to the frontal cortex can change behavior and personality forever, as the case of Phineas Gage demonstrates. Sometimes cancer surgeons have no other choice. These cases are not common, but the Damasios have seen a dozen patients with many of the same symptoms as Phineas. All have frontal cortex damage. All have trouble making decisions on personal or social matters. All react with little empathy and seem to find emotion a foreign language. To study these modern-day Phineases, the Damasios have far more sophisticated equipment than Dr. Harlow did. They have the full arsenal of CTs and MRIs, non-invasive brain scanners that can electronically slice up a brain and lay it out level by level like the floor plan of a house. But the Damasios also do simpler tests. Emotional response is difficult to measure, but there is one usually reliable sign of how you are feeling: sweaty palms. When your emotions are aroused, your skin, all over, and not just your palms, gets slightly warmer and slightly sweatier. Your sweat contains salts, which increase electrical conductivity. A person having a strong emotional reaction is going to spike a conductivity meter. It's the same principle used in the police lie detector test. Only the Damasios are interested in a different sort of truth. Hooked to a skin response machine, the modern-day Phineases are shown a series of emotionally charged pictures: a tranquil landscape, a beautiful woman, a severed foot. Their skin reactions are usually the same, nearly flat. The emotional colors of their world seem to have drained away. Another Damasio experiment involves a computer gambling game. There are 4 decks: A, B, C, and D. The decks are rigged. Normal subjects who play the game soon figure out that the C and D decks are better risks than the A and B. The modern-day Phineases keep playing A and B, though they can explain to the experimenters mathematically exactly why C and D are better risks. They realize the game is rigged to favor a slow but steady strategy against a risk-all strategy, but they still play risk-all. Call them Phineas's rules. So, what part of the brain controls this behavior? Dr. Harlow thought he had found the precise location of Phineas's troubles once he had the skull. By then, Phineas's actual brain was long gone, but Dr. Harlow knew enough gross anatomy to calculate that the iron had passed through the very front of the left frontal cortex. His answer was good enough for 1868. It isn't good enough today. Studying the brain scans of these Phineas-like patients, the Damasios wonder what a brain scan of Phineas Gage himself would have shown. In 1994, Hannah Damasio has an idea of how to construct one retroactively. First, she asked Dr. Albert Galiberta at the Harvard Medical School Let's have another look at Phineas's skull in the Harvard Medical Museum. Under the careful eye of the curators, Dr. Galiberter x-rays, photographs, and remeasures the skull. The results are digitized, so the specifics of Phineas's skull can be overlaid onto a three-dimensional computer image of a generic human skull. Back in her lab in Iowa, Hannah Damasio carefully plots the entrance and exit wounds. A line is drawn between their center point to lay out a hypothetical path for the tamping iron. The generic electronic skull is then adjusted to Phineas's specifications. Now, Dr. Damasio has Phineas's skull on a computer screen. She can tilt and rotate it in any direction, exactly as if she were holding it in her hand. Then she adds the tamping iron electronically. The real one tapers, but the electronic one is represented as a cylinder, as big around as the fat end of the tamping iron. Now, Dr. Damasio turns to a computer program called BrainVox that is used to reassemble brain scan slices into a three-dimensional model. BrainVox fits this electronically scanned brain inside Phineas's electronic skull. The brain is a very small place, and a very small change in the path of the iron would have had very different results. BrainVox calculates 16 possible paths for the iron to follow through Phineas's head. The anatomical evidence from Phineas rules out 9 of these. Dr. Damasio knows that the iron missed his jawbone, lightly clipped the interior arch of his brow, and knocked out 1 molar, but didn't destroy the socket. Any path that falls outside those landmarks is out of bounds. Of the remaining 7 routes, 2 would have cut important blood vessels and would have killed Phineas instantly. BrainVox lays out the last 5 routes. The Damasio team whittles it down to 1. BrainVox plots it as a red cylinder passing through the animated computer skull. The top of the skull is open to show the rod emerging from the frontal cortex. It is a riveting image. The scientific journal Science put BrainVox's images of the pierced skull on its cover, and it caused a sensation. Whether you're a brain surgeon or a 6th grader, the first time you see the BrainVox images of Phineas's head with that red bar through it, you wince. If you study the animated skull from different angles, you can see Phineas's incredible luck. The iron passes through his head at a very steep angle. That's both his salvation and his ruin. It misses a number of key areas on the side and top of the brain. On the left temple, it misses Broca's area for speech. On top, it misses 2 key sections of the cortex, the motor and somatosensory strips. These areas integrate your sensory input and muscle actions, so you keep oriented in space and in motion. Thus, Phineas is left with the ability to keep his balance, to focus his attention, and to remember both old and new events. The tamping iron, however, plows on through his frontal lobes, passing through the middle where the 2 hemispheres face each other. The iron damages the left hemisphere more than the right, the front of the frontal cortex more than the back, the underside more than the top. Dr. Damasio recognizes the pattern. Phineas's reconstructed brain matches brain scans of her patients who had cortex tumor surgery. Humans have always argued about what makes us human. Is it our ability to walk on 2 feet, to hold tools in our hands, to speak and hear language, to worship a supreme being? The case of Phineas Gage suggests that we are human because our frontal lobes are set up so that we can get along with other humans. We are hardwired to be sociable. When we lose that ability, we end up like Phineas. His closest companion was an iron rod. The tamping iron and skull of Phineas have a new home at Harvard Medical School in Boston. After 150 years on display, just outside the dean's office in the medical school, they were cleaned up and moved in 2000 to a new exhibit case in the Countway Library of Medicine just down Shattuck Street. If you want to see Phineas, you have to ask permission at the library's front desk, but generally they will send you straight up to the 5th floor where Phineas resides in Harvard's collection of medical curiosities.